This video is for Chemistry in the Earth System, Unit 1.5, Tectonic Plate Interactions. Today's essential question is, how do the different types of plate boundaries interact, and what features do they create on Earth's surface? Hello, baby birds! Earth's surface is not solid and unchanging. Instead, it's broken into large pieces called tectonic plates. And these tectonic plates float on the semi-fluid asthenosphere beneath them. These plates interact in three fundamental ways. They collide, they move apart, or they slide past each other. Understanding these interactions explains the biggest forces that shape our planet: mountains, volcanoes, earthquakes, trenches, as well as rift valleys. In this video, we'll not only look at the science of these boundaries, but also explore cultural stories from around the world. And these stories show how people living in tectonically active regions made sense of the same phenomena long before plate tectonics was developed as a scientific theory. A convergent boundary happens when two tectonic plates move toward each other. These collisions can occur in three combinations. We have oceanic and continental convergence. A dense oceanic plate meets a lighter continental plate. Or we have oceanic and oceanic, in which two oceanic plates collide. Or we can have continental to continental, in which two continental plates push together. The key process here is compression, meaning the plates are being squeezed. Now, when one plate is denser than the other, it sinks beneath the other in a process called subduction. This is especially common with oceanic crust, which is denser than continental crust. So, let's unpack subduction a bit more carefully. Oceanic crust is made of basaltic rock, which is dark and dense. Continental crust, on the other hand, is made of lighter felsic or granitic rock. Now, because of this difference in density, when an oceanic and a continental plate meet, the oceanic plate always sinks beneath the continental plate. This sinking creates a subduction zone. At a subduction zone, oceanic crust is literally recycled back into the mantle. It is the friction between these plates that causes earthquakes. Now, as the plate melts while it's being recycled, magma from that recycling rises and then fuels volcanoes. So, subduction zones are places of destruction as well as creation at the same time. The Himalayas give us a perfect example of convergent boundaries. About 71 million years ago, the Indian plate began drifting northward. Then, about 10 million years ago, it collided with the Eurasian plate. This collision did not involve subduction, because both plates carried continental crust. So, instead of subduction, the crust was compressed, folded, and then uplifted, creating the Himalayan mountains and the Tibetan plateau. Today, Mount Everest stands 8,848 meters tall. In fact, the Himalayas are still rising. In places like Nanga Parbat, the uplift rate is about 1 centimeter per year. Looking into the future, geologists predict India will continue to move another 180 kilometers inland over the next 5 to 10 million years. For Tibetan Buddhists and Hindus, mountains are sacred. They're seen as the axis mundi, or axis of the world, which connects earth and heaven. Across the globe in South America, the Andes Mountains also formed by plate collision. The Inca saw these peaks as apus, or sacred mountain spirits, believed to control weather and agriculture. Again, both scientific and cultural explanations reflect how mountains dominate human imagination. Now, instead of pushing together, plates also pull apart. This happens at divergent boundaries. Here, tensional forces stretch the crust. Divergence can occur in two ways: oceanic divergence, which creates mid-ocean ridges as magma wells up and forms new seafloor, as well as continental divergence, which creates rift valleys as the land splits apart. One of the best known divergent boundaries is the mid-Atlantic ridge. So here's the process. First, heat from the mantle makes the lithosphere buoyant. Then magma rises through fissures, or breaks in the crust, creating new crust. And then that crust slowly moves away in the opposite directions, a few centimeters per year. Now, over millions of years, this has created a ridge that bisects the Atlantic Ocean and even continues around Africa into the Indian Ocean. This is proof that Earth's crust is constantly being created. Now, in East Africa, where continental divergence is happening, the Great Rift Valley is not only a geological marvel, but also the cradle of mankind. Fossils like Lucy in Ethiopia connect this geologic site to our shared human story. Local traditions also tell origin stories tied to this land. Similarly, the Red Sea, formed by divergence, is referenced in Islamic and pre-Islamic traditions as a place of dramatic earth-shaping events. The third type of plate boundary is the transform boundary. Here, plates slide past one another. Here, no crust is created or destroyed. Instead, stress builds up as plates grind together. When that stress, which is building up, exceeds the rock's strength, it suddenly releases as the rock breaks. This process is an excellent way to understand energy transformation. Stress creates potential energy, and when the fault slips, meaning when the rock breaks, the energy becomes kinetic energy, and the ground shakes as an earthquake. One of the most famous transform boundaries is the San Andreas Fault here in California. It is about 1,300 kilometers long. On one side is the Pacific Plate, carrying Los Angeles northward. On the other side is the North American Plate, carrying Sacramento. Over millions of years, these cities may one day sit side by side. Various native Californian peoples told stories about earthquakes being caused by powerful spirits moving underground. Also, in New Zealand, the Maori say earthquakes are caused by gods beneath the earth. Both explanations highlight the human attempt to understand sudden, violent shaking of the land. Now, subduction zones create dramatic features, one of which are ocean trenches. These ocean trenches are deep, V-shaped valleys marking where plates dive. Most trenches circle the Pacific in the Ring of Fire. This Ring of Fire is a zone that produces 75% of the world's volcanoes and 90% of the world's earthquakes. Another feature that's created are volcanic arcs. These are chains of volcanoes parallel to the subduction zone. Examples include Japan, the Philippines, Tonga, and the Aleutian Islands. The Ainu of Japan described volcanic eruptions as the work of the gods. The Aleut people have oral traditions of quakes and eruptions in the Aleutian Islands. These align directly with scientific observations of volcanic arcs. But not all mountains are the same. Here are two examples of different types of mountains. Folded mountains. These are formed when plates collide and compressional forces crumple rock into folds called anticlines and synclines. Some examples of folded mountains are the Andes, the Himalayas, and the Rocky Mountains. We also have fault block mountains. Fault block mountains are formed when extensional forces break the crust into blocks. Some of these blocks rise, called horsts, and while others sink, called grabens. Examples: the Tetons of Wyoming and the Basin and Range region. Both the Andes and the Himalayas were deeply sacred to local cultures, showing that mountain building is not just geologic, but also cultural. Two other important processes include rift valleys, or can be found in rift valleys when continents split apart. One example that we've already mentioned is the East African Rift Valley, which contains dramatic landscapes, lakes, and even the birthplace of mankind. We also have accreted terrains. These are when chunks of crust are scraped off of oceanic plates and then welded onto continental crust. Some examples: the Pacific Northwest of North America. Multiple indigenous tribes living on the coast share oral traditions that, in their own various ways, describe the land as rising from the sea. And that's exactly what happens when terrains accrete. New land appears where ocean once was. So, let's summarize. Continental boundaries build mountains, trenches, and volcanoes. Divergent boundaries create rift valleys and mid-ocean ridges. Transform boundaries create earthquakes. Processes like accretion help continents grow. From the Himalayas to the Andes, and from Japan to California, from East Africa to the Pacific Northwest, plate tectonics explains Earth's most dramatic features. At this point, you should be able to generate a full and appropriate response to today's essential question: how do the different types of plate boundaries interact? And what features do they create on Earth's surface?